Now our topic is the projectile motion. So the first thing that comes here is, what is a projectile? So projectile can be defined as any object or anything that can be propelled in air, right? And which is allowed to move only under the action of the gravity. So that kind of a thing can be defined as a projectile, right? So projectile we can study in two ways. In one way, we will try to move an object or throw an object horizontal to the surface of earth and then try to find the movement of the projectile, right? And other thing is, when we try to project a projectile or move a projectile with an initial velocity at an angle from the surface of earth, right? So that we will try to understand. So in first case 1, when a body in this case, here in this case is a projectile, is thrown horizontal to the surface of earth. So suppose this is the surface of earth, and at a particular height, suppose this height is h, we have thrown a body from a point, suppose O is the point from where the body is moving with an initial velocity u, right? There is the initial velocity u which is horizontal to the surface of earth. Suppose that is the surface of earth. And because projectile is a body which moves under the surface, under the gravity of earth alone, so after some time, after traveling a horizontal distance, suppose some time, it will remain straight to the surface of earth, horizontal to the surface of earth, but as the gravity will act on the body downward, right? Because gravity try to attract the body, okay, or try to make that body move towards it, so the body slowly move towards the surface of it, try to bend itself downward, okay? So at certain point, suppose P, the body is at point P and has traveled a distance y. Suppose that point has a distance x and has the coordinate x and y. So y is basically in the negative direction because body is moving downward. Suppose at point P, this is the distance body has traveled. So that is the y, minus in minus sign because it has moved downward, right? This distance minus y, and this is the distance along the x-axis, right? So by that time, its velocity, suppose now has become v, right? That is the new velocity, body at point P. Initially at point O, its velocity was only u. Now its velocity has become v, right? So we'll try to find out what is the velocity component at point P and at point P along x-axis and along y-axis. Suppose that is the point P and body is moving downward velocity v, right, as is in this case. So this can be resolved in two components, one along the x direction and other along the negative y direction, because body is moving downward. So the velocity component along y direction would be something, okay, and it will depend on the direction of velocity with respect to x or y. Suppose with respect to x, its distance, its angle is theta. So velocity along x direction now would be v cos theta, right? And here in this case would be v sin theta. So the velocity at point P would be this much, right? Then we will try to find out what is the horizontal range. Okay, suppose when it will come down to the surface of earth, it will travel a distance which is h. Suppose or if this is h, so this suppose is capital H. Okay, or suppose that is r. So when it's moving a distance along x-axis along the surface of earth, that is suppose is r, and the distance or the height from the surface of earth is h, right? Now we know this formula, S is ut plus half at square. So by this we can find out what is the distance. Okay, so when we'll try to find what is the motion of the projectile along x-axis and y-axis, we will have the proper distance for x and y-axis. Suppose for x-axis, so horizontal distance, suppose that is the horizontal distance traveled by the projectile at the finish of its journey. So suppose along x-axis there is sx, then ux is the horizontal component along x-axis, plus half ax into t square. Okay, so ax here is 0, which is the acceleration along x-axis. We already know that the projectile is a body which is moving only under the influence of the gravity alone. What does it mean? It means it has an acceleration along y-axis, because earth tried to attack the body downward, which is along the y-axis. Okay, and that is the acceleration, which is g. So acceleration on y-axis is g, but there is no acceleration along x-axis. So along x-axis there is no acceleration, means 0. Suppose if the body would have an engine which is trying it to propel along x-axis, in that case it would have an acceleration. Okay, but here in this case there is no engine, nothing is there. So the projectile can also be defined as a body which is not added, which is unadded by any engine. Okay, so there is nothing that can make that can give it any acceleration. So the acceleration along x-axis is always 0. So here it would be 0. And what is the velocity along x-axis? You know, velocity along x-axis and ux is the initial velocity, which was u earlier, we already know it. So sx, which is nothing but previously we have said that is the distance along x-axis. So distance along x-axis here is r. Okay, so what you can write here is that is the r. Okay, so you can put these values ux and r and ax in equation number 1. So what is sx? Sx is ux t plus half ax t square, which is nothing but ux is u, t suppose is t, plus half ax is 0 and t square. So that would be u, t, and sx we know is r. So what is t then? T is equal to r upon u. So that is the total time traveled. Okay, that is the total time that body has taken to travel a distance r along x-axis. Similarly, you can find the velocity along the y-axis. Okay, so the vertical distance is what? We already know it. That is h. Okay, so that would be sy plus uyt plus half ayt square. In that case we know here that sy is, what is this? Sy is minus h. Why it is minus? Because it is going downward. Uy was 0 because initially body was going in this direction. Okay, that was the initial velocity, which is u. Okay, so there is no acceleration along y-axis. Initially there was no acceleration, it was only moving along the x direction, and along y direction there is no velocity. So here uy is 0, t plus half. Ay is what? I already said ay is g, okay, and which is moving in the downward direction, so that is minus g into t square. So minus h is equal to minus half g into t square. So you can put this value here is h is equal to half or g by 2 t square. But we know what the value of t is, this much. So you can write h is equal to g by 2 into t square. What is t? R upon u whole square. So that would be, you can write it as twice of h divided by g, and that is u square is equal to r square. Okay, so that is your velocity, and there is nothing but the direction, but the you can say is the equation of a parabola, right? How can you, it is how can you say that that is the velocity of a parabola? Because we know that parabola, what is a parabola? Parabola is, suppose, is of this shape, where this can be written as y square is equal to 4x, some 4x, suppose, okay. Or if suppose if it is in this direction, in that case that would be x square is equal to 4ay. But what we have here in this case, we have 2h upon g u square is equal to r square. Okay, so when you see this thing, you know that the body is moving downward, okay, with initial velocity u, and it has traveled a distance along x-axis. This is your x-axis, which is r, right, and this distance is along the y-axis, which is h. So if I'll take this much, if suppose parabola is of this shape downward, then this would have been x square some minus 4ay, something like that, or whatever. So here in this case you can see, in place of h you can put, in place of y you can put h here, so that is be 4a some h, and in place of x you can put here, what is x? X की जगह पे क्या है यहाँ पर? Here in this case is r, so you can write r square. So it is resembling to this equation, so you can write r square is equal to some 4a h. What is 4a here? So 4a here is, where 4a here is 2 by g of u square. So if you replace 2 by g u square with 4a, you will get this equation, which is nothing but is the equation of a parabola. So which is, you can say, the equation of a parabola, right? So now we will try to find the equation when the parabola, when